Now this is a fact-based question from organic chemistry. Question says aspirin is known as. Now aspirin is a very important molecule, and that's why many times question is asked on aspirin. Now this molecule is aspirin. So you have COOH here, and then you have O, C double bond O, CH3. This molecule is aspirin, and this is a painkiller, and this is used as a painkiller. Now this is used as a painkiller. Now to remember the structure of this molecule is very easy. Now this molecule is called salicylic acid. So if you have COOH group here and you have OH, and this molecule is called salicylic acid. Now in place of acid group, if you put CHO group, if you put CHO group here, then this is called salicylaldehyde. So in this case this is called salicylaldehyde. Now if you see what is happening in case of aspirin, you have removed hydrogen and placed CH3CO group. Now CH3CO group is also called acetyl group. So this group is called acetyl group. So this group is called acetyl group. So now what we will have, so name will be, so this is a salicylic acid and this is acetyl salicylic acid. That is the option number 4. So we will have option 4 is the correct in this case. That is the acetyl salicylic acid. So this is acetyl salicylic acid. This is again a fact-based question from carbohydrate chemistry. Question says, which of the following compound can be detected by the Molis test? Now you see, this is basically a test of carbohydrate, and carbohydrates are sugar. So if you simply remember this kind of test, Molis test is used for carbohydrates, the option 1 is the right answer in this case. So option 1. Now what happens in this test, and Molis test is used for the detection of carbohydrates. So carbohydrates are detected by Molis test, in which what happens in this test, a small amount of alpha naphthenol is added to the compound. So we have compound, my carbohydrate is here, and if we add alpha naphthenol, so a small amount of alpha naphthenol, basically alpha naphthol is added, and the concentrated sulfuric acid is dropped carefully. So we also add conc sulfuric acid, conc H2SO4 if we add. If the compound is carbohydrate, then violet ring is obtained at the junction of two liquids. So alpha naphthol and this carbohydrate, we will find a violet ring at the junction. So you will find this is a violet ring at the junction. If you remember, the same kind of test is also possible, and that is called brown ring test in inorganic chemistry. If you have some idea, in inorganic chemistry we have something called brown ring test. Same thing happens there also. In this case you have violet ring, in that case you will have a brown ring that forms, and that's why this is called brown ring test, because there is a ring that is formed. So inorganic chemistry qualitative analysis chapter, and this is a test of NO, basically nitrate ion NO2 minus. Now this is question from electrochemistry chapter. So question says, the standard reduction potential of Zn2 plus Zn, Ni2 plus 2Ni, and Fi2 plus 2 Fe are given 0.76 minus 0.23 and minus 0.44. The reaction will be a spontaneous when. So we have to find in which case reaction will be a spontaneous. So let us say if my X is nickel, so let us check one by one. X is nickel, this will form Ni2 plus 2E. Now Y is basically zinc, so I will have Zn2 plus 2E, and this will give me zinc. Now E degree for Ni2 plus, that is the reverse of this. I will have plus 0.23 because reduction potential is given, but now I am writing oxidation potential. Now Zn2 plus to zinc, and this is minus 0.76. Now if we add these two quantity, E degree is coming out to negative, so E degree is, this number is coming out to negative, so this reaction is not a spontaneous. So this is not a spontaneous reaction. Let us check the second option. You have X is iron, so you have Fe2 plus 2 electron, and now E degree value in this case you will have Fe2 plus 2 Fe, that is minus 0.44, so I have reversed, so this is 0.44. Now the next is by is zinc, so I have Zn2 plus 2 Zn2 plus 2E, and this is basically zinc. Now in case of zinc, what is the E degree value? E degree is minus 0.76. This is minus 0.76. Now if we add these two things, again E degree that is coming is negative. You see here minus 0.76, this is plus 0.44, so this is negative. So this is again, this reaction is not a spontaneous. Now let us check the next reaction. You have X is zinc and Y is nickel. So you will have X is zinc, Zn2 plus 2E, and Y is nickel, that is nickel 2 plus 2E, and we have to form nickel. And zinc, in this case you have Zn2 plus 2E, that is the minus 0.76, so I have to reverse this one, so this is plus 0.76. And Ni2 plus to Ne, so Ni2 plus Ni, that is 0.23 with minus sign, so minus 0.23. Now if we add this reaction, in this case E degree is coming out to be positive, so E degree is basically positive in this case. So this reaction is basically a spontaneous, so you have Ni2 plus, and this will give you Zn2 plus Ni, and now this case reaction is a spontaneous. So option 3 is the right answer in this case. Option 3 is the right answer in this case. So you see option 3, basically we have checked this one. Now this is an easy problem. Question says orthonitrophenol is less soluble in water than para and metanitrophenol because. So this is again a case of hydrogen bonding. So you have nitrophenol, orthonitrophenol. So let us say you have OH group and here you have NO2. So this is your orthonitrophenol. Now if you see in this case you have hydrogen bonding between oxygen and hydrogen. So what is happening due to this hydrogen bonding, there is an intramolecular hydrogen bonding. This forms less hydrogen bonding with H2O because it is sufficient. It is the hydrogen bonding is formed between the molecule, between the basically inside the self molecule, that is the intramolecular hydrogen bonding. So in this case we have intramolecular hydrogen bonding. Hydrogen bonding. So what is happening? orthonitrophenol is satisfied with the intramolecular hydrogen bonding, then there is no reason it will form intermolecular hydrogen bonding. So in this case, option A is the correct option because it forms intramolecular hydrogen bonding. It is less soluble in water. So option 1 is the correct answer. Less soluble in water because of the intramolecular hydrogen bonding. Due to intramolecular hydrogen bonding. This is not the case with para and metanitrophenol because in that case groups are far away. So if you have a para and metanitrophenol, in this case intramolecular hydrogen bonding is not possible. Basically in these cases intermolecular hydrogen bonding happens. So in this case intermolecular hydrogen bonding occurs. So it can form bonding with H2O and this is more soluble. Now this is again a straightforward question. Question says iodoform can be prepared from all of the except. So which of the following will not give iodoform? So if you remember, iodoform test or iodoform can be prepared by methyl ketone group. So if you have methyl ketone, that is basically methyl ketone, that is CH3CO group, it will give iodoform test or it will form iodoform. In some cases, even if you have CH3COH, it will also form iodoform. What happens? This COH group first gets oxidized and it forms, so after oxidation, so it gets oxidized and after oxidation it forms methyl ketone. So this also gives iodoform test. Now the first is isopropyl alcohol. So you have CH3CH. So this is CH3CH. So I will have CH3OH. And this is your isopropyl alcohol. Now if it gets oxidized, it will form CH3CO, CH3. So now I have methyl ketone, so it will give iodoform test or it will form iodoform. Now the second is 3-methyl 2-butanone. So I have butanone, so 1, 2, 3, 4 and 3-methyl 2-butanone. Once again this will form iodoform because I have methyl ketone group, so it will also form iodoform. Now 3 isobutyl alcohol. So isobutyl alcohol is CH3CH, CH3. This group is called iso group, CH3CH, this group is called iso group. Now I have to have butyl, so I have 3 carbon, again 1 carbon OH. So this is isobutyl alcohol. Now in this case, this does not have methyl ketone. Even if you oxidize, you will have CO, but I does not have any methyl group here. So this will not form iodoform. So in this case, no methyl ketone. So no methyl ketone is formed. So no iodoform test. So no iodoform. So in this case, you cannot form iodoform, and that is basically option 3 is the correct answer in this case. So option 3 is the correct answer. This is again an easy problem. Question says the species which can best serve as an initiator for cationic polymerization. Now what is cationic polymerization? I form a cation, and now cationic polymerization is basically starts by Lewis acid, or you can have H plus also in some cases. So now for cationic polymerization, what happens? You have a double bond, and this double bond goes to somewhere so that polymerization start. Either you can have H plus, that is basically acid, or you can have a Lewis acid. If it does not have H plus, you can have a Lewis acid, and that can start polymerization. Now among these three, best sharp. Now I need best. So among all these, AlCl3 is the Lewis acid because this polymerization is best done by in the presence of Lewis acid. In place of HNO3, this is a strong acid. It will basically do the side reactions also. Generally, polymerization is done in the presence of Lewis acid. So I can remember polymerization starts with Lewis acid. Now in this case, only one Lewis acid we have, AlCl3. So AlCl3 is the Lewis acid because it has 1, 2, 4, 6 electrons. So this is a Lewis acid. So answer will be 2 in this case. So option 2 is basically correct answer. Now this is again an easy problem from chemical equilibrium chapter. Question says the equilibrium constant for a reaction N2 plus O2, and this gives you 2NO. So N2 plus O2, and this gives you 2NO, and the Kc for this reaction at a given temperature T is 4 into 10 to the power minus 4. So this is given. The value of Kc for this reaction at the same temperature will be. So we have to find NO plus half O2. So the value of Kc for this reaction, NO plus half, this is basically NO goes to half N2 plus half O2. So we have to find equilibrium constant for this reaction. So what we can do is, let us do some manipulation. First, if I reverse this equation, that is 2NO, and this gives you N2 plus O2. So if I reverse this equation, the equilibrium constant will be reversed, that is reciprocal. So I will have 1 by 4 into 10 to the power minus 4. So equilibrium constant for this reaction is this. Now if I divide by 2, so I will have NO plus, that is goes to half N2 plus half O2. So if I divide by 2, I have to take root this side. So K is now root over 1 by 4 into 10 to the power minus 4. So this is basically, if we take root, so this is 2 into 10 to the power minus 2, that is 100 by 2, and this is basically 50. So in this case, equilibrium constant, all are Kc value because we are manipulating Kc. So let us call this as a Kc dash. Equilibrium constant for this reaction is Kc dash, and that is 50. So your answer is 3. So option 3 is the correct answer in this case. This is a formula based problem from chemical kinetics. Question says, for a first order reaction, the concentration of A changes from 0.8 to 0.025 m in 40 minutes. The rate of reaction when the concentration A is 0.01 m. So we have to find what is the rate when concentration is 0.01 m. So for first order reaction, we have rate constant K is equals to 2.303 divided by T log A by A minus X. So this is the equation we have for first order, and we can find K 2.303. In this case, time is given, so it takes 40 minutes. Log A, initial concentration changes from 0.1 m to 0.025. So this value is 0.025 because this is the left concentration. So we will have 2.303 by 40 log. This is basically, you can write this is you can have 100 divided by 25, so this is 4. So you can do yourself. This is 1 by 10 and this is 25 by 1000. So this is 100 by basically 10, 25. So this is 4. So log 4. So you will have in this case, and log 2. I can take 2 outside. So you have 2 into 2.303 by 40 into log 2. So this is the rate constant K value. Now we have to find what is the rate of reaction when concentration is 0.01 m. So rate is given by, for first order reaction, K times concentration of A, and the concentration is 0.01 m. So rate will be equilibrium constant K, this is rate constant K, to 0.303 divided by 40 and log 2, and this multiplied by this concentration is 0.01. So you see here this concentration is 0.01. So we have to find when this is 0.01. Now log 2 is 0.303. So we can write 2 into 2.303 into 0.303 into 0.01, and this divided by 40. So we can do this calculation. So this is, so let us say I can do this one here, 2 into 2.303 multiplied by 0.303 into 0.01 divided by 40. So this comes out to be 3.49 into 10 to the power minus 4. So 3.5 around 3.5 into 10 to the power minus 4. So we can check here. So we have here 3.47 into 10 to the power minus 5. This is the correct answer. This is around approximately same. So this is option 2 is the correct. Oh, so 10 to the power minus 4. So 10 to the power minus 4 is option A. So in this case I can say option 1 is the correct answer. Now this question is from metallurgy chapter in organic chemistry. Question says, which method of purification is represented by the following equation? So this is, first, titanium forms a compound. This is a basically volatile compound, and when this at high temperature, this decomposes into titanium plus iodine. Now this is a basically method for one arcyl process. What we do, very pure titanium, so we can use, so we using one arcyl method, we can basically find or we can produce ultra pure metal. So this can be used to ultra pure metal. And what we do in this method, so we have impure metal, and we add some gas. So if we add some gas and we make a compound, this is basically generally volatile compound. So this is volatile compound. And if we do this volatile compound at very high temperature, heat at very high temperature, I can get the pure metal here. So we will get pure metal. So this is the idea behind one arcyl process. So what we do, we have an impure metal. Impurity remains as it is. Impurity does not form volatile compound. So impurities does not react with this gas. Are you getting? Now what we are doing in this case, we have metal, this is impure. Now react with iodine, this is TiI4, this is a volatile compound, gas. Now further heating, I can get titanium, and this is a solid, and this can be easily separated. So this process is called one arcyl process. So option 3 is the right answer in this case. That is the one arcyl process. So this is all behind one arcyl process. Now this problem is from inorganic chemistry, slightly logic based problem. Question says, Iron exhibit plus 2 and plus 3 oxidation state. Which of the following a statement about iron is incorrect? So we have to find incorrect statement. So we have iron 2 plus, Fe2 plus, and we have Fe3 plus. In one case this is called ferrous, and in another case it is called ferric. Now ferrous compounds are relatively more ionic than corresponding ferric compound, and this is true. If you have a more positive charge, it will do more polarization to the anion. So this means Fe3 plus will more polarize the anion. So if it will polarize more to the anion, this means compound will be covalent in nature. Now the second option, so first option is correct. So option 1 is basically correct. Now let us check option 2. Ferrous compounds are less volatile than corresponding ferric compounds. This is also true because ferrous compound is more ionic because less covalent character. So this is more ionic, and ionic compounds are basically solid. So this is less volatile because this is more ionic, this is less volatile. So this option is again correct. Now let us check option number 3. Ferrous compounds are more easily hydrolyzed than corresponding ferric compounds. Before discussing option 3, let us discuss option 4 and then we can say something about option 3. This says ferrous oxide is more basic. So I have ferrous oxide and I have ferric oxide. This is, I can say this is more ionic. So more ionic, and this is less ionic. Now see, this is more ionic. This means it is more basic because it can dissolve into the solution easily. So this is more basic. So ferric oxide is more basic. So in solution it will produce more OH minus. So this option, that is ferric oxide is more basic in nature than ferric oxide, this is also true. Now we have only option 3. Even though we does not know the answer, this has to be the correct choice. Now ferrous compounds are more easily hydrolyzed than corresponding ferric compound. This is basically not true. Ferrous compounds are ionic. Generally covalent compounds are easily hydrolyzed. Generally covalent compounds are easily hydrolyzed. So basically option 3 is incorrect. So in our case we have to find incorrect. So option 3 is the right answer. So option 3 is right answer. Now this is from atomic structure. The electrons identified by the quantum numbers n and l can be placed in order of increasing energy. So we have to find which has highest energy and then which has lowest energy. So this is n is equals to 4. So this is 4 and L is equals to 1. So you have L is equals to 0, that is s orbital, and then you have L is equals to 1, this is p orbital. So L is equals to 2, this is basically I have d orbital. So now this is for p because L is equals to 1. So this is first is 4p and this is 4s. This is 3 and L is equals to 2, this means 3d. Now this is 3p. So these are the corresponding atomic orbitals. Now you see we can place them in increasing order of energy. So we have, so lowest energy we will have 3p has the lowest energy, and then we have 4s, and then we have 3d, and then we have 4p. So 4s comes before 3D. So this is the increasing order, that is, this is the A, this is B, this is C, this is D. So we have to have 4P, this is basically A, 3D, this is basically C, and this is 4S, this is B, and 3P is basically D. So increasing energy order is DBCA. So we have DBCA. So option A is the correct option. So option 1 in this case is correct answer.